got on the wrong flight. And these are Dan Moniz and Patrick Stack, and they're going to talk about breaking LANMAN forever, which is a continuation of the sort of work that's been going on to look at password hashes and the rainbow tables.
Thanks. Everybody hear me? Yeah? Okay. So I'm Dan. This is Patrick. Patrick, say hello.
Hello.
What we were trying to do with this presentation was give an idea and a release of some stuff we've been working on essentially for about a year. This is the Breaking LANMAN Forever talk. And basically, what we were looking to do was we started out in Shmoo at the end of 2004 with this effort where Beetle basically said, hey, could we use Rainbow Crack to just generate the largest possible set that Rainbow Crack would allow you to generate for LANMAN hashes. And the theory, we all sort of, I didn't really look at it very hard, and then we all looked at it and said, oh, well, this would be cool to do. We can put a bunch of machines behind it, we can get it rolling and whatnot. Where's Rodney? I want to see if you can get over there somehow. In any event, so we did that. We basically, myself and another Shmoo put together a bunch of machines, and then other Shmoo helped to organize and do filtering and verify the tables. Has anybody who's here has seen or downloaded some of the rainbow tables off of our site? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Okay, so about 20 some odd people or so. Who here has had problems with the tables that they've downloaded off the site? Anybody? Okay. Has anybody used them to crack actual passwords yet? Sweet. Okay, cool. So you like them? They're working, right? All right, cool. So we did that, and the problem was that we found a couple things. One, last Shmoocon, I wanted to kind of do a little release. I didn't have a talk prepared, but we wanted to do a release and announce the fact that we had generated all this stuff, and we were going to give it away for free. But it turns out that it was a good thing we didn't have time to announce it because we did the wrong set by accident. We actually did the set that includes every single valid input character to LANMAN except space. So, yeah, exactly. It's like one of these, But it gave us a little bit of time to step back and say, hey, okay, let's go back and do the right one. Let's figure out why we did the wrong one in the first place. And I started talking to Patrick, who's a friend of mine, and who is working on a lot of factoring and other crypto issues around the same time. And I said, hey, we had this project, we did this thing, we messed it up by accident. We're going to go do it again, but I'm looking at this code and it does not, the method does not look good. And do you have any optimizations? It looks kind of slow for what it should be. And he said, well, I'll take a look at it, and get back to you on it and we'll see what we think. So you want to take it from here for a bit?
Well, basically, it's probably pretty good that you can download Rainbow Crack for free because the algorithms it uses are very slow. For example, whenever you crack, it actually reads all of the data from disk, and as we all know, disk is very slow. Oh, yeah, the points. Also, as far as the methodology that Philippe Olstein, the paper that Rainbow Crack was based on, it's based on statistical coverage of the key space, and it's originally an idea developed by Martin Hellman in 1980. I'd have to look at my bib tech. Yeah, about 1980. Well, in 1980, a computer with 4 megs of RAM cost about $250,000, and that's why you had to statistically complete the key space for an algorithm that has 2 to the 56 possible inputs. Now, in the case of LANMAN, you're talking the summation of 0 to 7, 69 to the I, so it's much smaller than even 2 to the 56th. So the point being, statistical coverage might have been cool in 1980, but now we actually have computers that can do things like this, and
I may just be the only person in the room who doesn't know the difference between statistical and complete coverage. Maybe.
All right, so statistical coverage means you have a 97% chance of, getting it, right? But there's that 3% chance that you miss, always, given enough samples. Now, complete coverage and having it verified means you always have guaranteed 100%. There's not even like the slightest margin of error. It's, yeah, without making a really bad analogy in DC about government labor, I'll continue. But we can do better. Started from scratch with all new code and a better algorithmic approach. We were still interested in Philippe Olstein's basic idea of avoiding merging chains. And what this is where two of the chains you would compute would merge because the reduction algorithm would yield the same value even though it was reducing two different values. So thus you would have the same end output value, making the two chains worth the equivalent of one. So he found a way around this. However, we assume that we could get runtime on huge machines and clusters with tons of RAM for compensating for the statistical coverage, and that we could use 1 bit per possible input and actually verify that we had computed every key.
So you should talk about like a bit mask.
Okay, so 1 bit per key. If the bit is 0, we haven't computed the key. If the bit is 1, we have. And so as you compute, you just set bits. And that's kind of how it works. Geared more towards optimal crack time rather than ease of use by regular Joes. And what this means is, like, we weren't concerned that, like, we could give the code to, like, Tommy with his Pentium 4 2.4 gigahertz with half a gig of RAM, and that he could generate his own tables. Because really, like, why have everyone waste a whole bunch of CPU time when you can just distribute the data for it? We still haven't named the project. It's been a year.
I'm personally going for Snazzy Wiggles for no reason.
But
It's true.
the code that generated the 5/6 character space, the bit mask required to verify the space was 12.745 gig of RAM. We could have used file back storage. However, as anyone knows, swapping is painful, as disk I/O takes about 50,000 times as long as referencing memory. Code which did the 7-character input space needed 866.87 gigs of RAM.
Who here has that? All right, we got to talk later.
Well, we did. So we had runtime on a large SGI Itanium 2 cluster with 512 CPUs and a tera of unified memory, although we have yet to get the data back. Which is, yeah. All right. So some of the optimizations. For LANMAN DES, it can only actually hash up to 14-character passwords. However, because of the input range of DES being 2 to the 56, it splits them into 2 independent hashes. Thus, you can detect if the second hash is the null hash, thus no input hash, that the first hash can be 7 characters or less. However, if it's not the null hash, you know the first hash is 7 characters. Thus, why bother trying to compute portions that have to do with anything other than 7 characters? So the optimizations for the 0 character or null hash, that's a single comparison. For the 1 to 2 character, the complexity is O of log 69 cubed, because 69 possible input characters. And the 3 and 4 character is log of 69 to the 7th. And then the other two actually use a modified B-tree algorithm, which B-trees are similar to binary search trees, only they optimize for memory page and disk I/O utilization by storing data in disk-friendly size pieces is the easiest way to describe it. Okay, single versus multiple tables. Part of the problem with doing it statistically is that as the size of a single table increases, the statistical coverage decreases. So what Philippe Olstein suggested is that you use multiple tables to compensate for this, because 5 sets of tables with 80% coverage actually take less time to compute and are more accurate and take less disk space than one large table using the statistical method. However, at crack time, you have to compute the summation of chain length, which, does everyone know what the exclamation point after a number means? Bang. Yeah. Yeah. Bang. But, all right, for example, 3 bang would be 1 times 2 times 3, thus 6,
Factorial,
right?
right?
Yeah, factorial. Yeah.
Everybody remembers factorial?
All right.
Vaguely.
So, but if you have multiple tables, then you have to do chain length factorial times number of tables. So with our method, using a single table, because we verify the whole space and don't have to worry about statistical coverage, we just use chain length factorial. This saves number of tables minus 1 times chain length factorial, number of computations, which the actual encryption portion of crack time eats about 50% of your time when cracking with Rainbow Crack. If you notice, it displays the pseudo-accurate statistics when it's done running. Rainbow Crack. The disk I/O complexity of this is O of n, which means it reads everything that you have on disk into memory. And disk, as I said before, is effing slow. Oft Crack. This was the one made by Philippe Olstein. It has an O of log of n complexity, which it's basically just a flat file binary search tree. You know, the old divide and conquer search where, you know, okay, it's less than my middle point now. I can take that and, you know, there and then divide. Yeah. All right.
People like the hand motions. Keep doing the hand motions.
It's hard to do it in reverse, too. It's easy to explain if you're standing beside somebody. Our code actually, because of the modified B-tree algorithm, has a complexity of this. And what these big O notations mean is it's an algorithm performance metric developed by Donald Knuth by number of permutations. Basically, you have to compute to a worst case scenario to reach the endpoint of an algorithm.
Right. This is all pathological cases in computability, right? So something that's over the n is ridiculously
And this is the
insane.
case, half of the time you spend with Rainbow Crack is used for disk I/O, if not more, if you're using, like, you know, standard parallel ATA and all that nice stuff.
All right, let me go after this.
All right.
So given all this, what's the release schedule? Well, it was supposed to be today, but we don't have code back from SGI. Well, rather, we don't have our data back from SGI. We're working on it. We have a couple other approaches. This code went through a couple different revisions when we were writing it in an attempt to, like, you know, first of all, if you look back at this one, let me go back. 866.87 gigs of RAM was, you know, more than we had easily available in one system, and it was unified memory. We wanted unified memory because we wanted to be able to address it all and do mmap. We didn't want to have to hit disk at all. Right, and also, yeah, right. The other thing too is that not only did we want to hit memory and never hit disk, we also didn't want to cross the network I/O boundary. So having a huge machine with a ton of processors, which were logically seen all as one gigantic processor, and the same thing for the memory space, made it easy to make the memory management of the code just basically write endlessly, you know, for as much as it needed. And the algorithm worked in that space. So we could estimate how much code, you know, or how much memory we were going to consume, and then just find a machine with that much unified memory. This says we actually had a runtime on a large SGI Titanium 2 cluster with 512 CPUs, 1 tera of unified memory, which is accurate. That 512 CPU Titanium 2 cluster is actually one of 2 machines that are networked together by NUMA-link, which is non-uniform memory architecture link. This is basically like when SGI bought Cray way back, they took all the Cray-link technology, which was this high-speed interconnect for, you know, huge supercomputers, and then renamed it, made it slightly better.
That's still slower than
Right, it's still slower than disk. So we stuck just to the one machine with 512 physical CPUs in it and didn't cross that boundary. We're all about, you know, how many CPUs can you give us in one box, basically. Who here has, like, huge machines with tons of CPUs? Can you guys, like, talk about numbers? Is it like, so it's all 64-bit Titanium 2 stuff? Really? Okay. Can you, like, use that, or is that? Don't make rainbow tables. We're trying to help you. 100%, dude. You could have all of the. You could have all the codes. Not just some of the codes, some of the time. If there's some, I have to take a little technical break. If there's somebody who can help us get this laptop on that screen, we would really love you. Does anybody know how to do that, or can find somebody that would know how to do that? Supposedly, we were told it was possible, so I have faith that it is, just that it isn't right now. I don't know. Okay, great. Thank you. Yeah, if worse comes to worse, we'll just unplug and switch. But I want to go back through because Patrick just dropped a whole ton of math on you. Who's confused, at least in part? All right. Yeah, who's not confused? Raise your hand. Okay. No, it's okay. I mean, it's expected, right? We ran through a bunch of stuff very quickly, very densely, and we want to give you. It could be easy to say, if I sat up here with a chalkboard and wrote some formulas and then said, obviously, right? So, duh. Yeah, that was his idea. So luckily, I'm here. The other thing that I want to point out is that I gave a really brief talk at DEF CON that was sort of outlining all of this stuff, and to some extent, this is not much different in as much as that we did include numbers, and we do have a bit more detail on the specific algorithm and the specifics of the breakdown. Part of that isn't because we don't have the actual stuff to give you. It's not as though I could we estimate that the total 7-character space is going to be 250 gigs of raw data, right? Right. So unpruned. There's actually a generation step where we generate all of the possible inputs and their hashes, and then we do a pruning step, which is basically to reduce everything that's redundant. And the pruning step takes, what did we? Yeah, 2x the generation step. We figured the generation step to get an idea of work involved. With this 512 CPU and 1 terabyte of unified memory, we had a block of, I want to say, 58 hours on the system that was donated to us. We ran for, I think, around 32. And we didn't finish, but we got close. I don't know exactly how close. Are we good?
Well, if I do this, I might kill video for both, but it pass through here.
Okay, well, we'll try it.
I think we need to change the input on this one.
Okay. Well, do whatever you need to do. That's cool. I can talk. That's fine. And I can see my own slides, so at least I can sort of explain things. So we ran for about 32 hours, roughly, we think. The job was interrupted accidentally by some other user of the cluster who had root and just kind of killed it. So, even on gigantic big iron and having great sponsors that were willing to give us stuff, we still had just user issues, which I guess is to be expected. But because of that, so we tried to get more time just to finish, right? We figured, okay, well, we had 58 hours. We probably would have finished in that. We estimated that we would finish within 58 hours, or maybe, maybe around 64 at the most. Sweet. No, he's on Linux.
Right, I know, but it's a hardware thing. On the IBM, it's a hardware thing. Function F7 gives you a...
I'm not seeing a pop-up of anything.
No, you should cycle through. There's 4 states, right? There's 4 possible states.
Okay, well, that's the nothing state right now, so let's see.
Do it again. Just go blind, man. Just throw it up there. Blind.
Become one with the code. Yeah, if worse comes to worse, we can switch it. Anyway, so we had that runtime, well, checking my email in front of you, we had that runtime, I want to say, in around May or so, and it was huge. We also had runtime before that for the 5.6 space, which we talk about over here. So we did the 5.6 initially because it had less requirements. It was only 13 gigabytes of unified memory as opposed to 870. So obviously there's a huge jump every time you go up in character input. The main problem was that so we did I think the 5.6 space pretty trivially. I forget how much time it took on the Itaniums. Yeah, 6 hours, which is nice. We never got around. We had this back and forth through intermediaries to try to get the sponsor to help us get more time on the cluster, and it never kind of worked out for various reasons, and it still hasn't. So as a result, we're still trying to work with them, just because if we did get time, between May and now, we haven't been able to get another window. But if we did, it would take a long weekend to finish, right? Like another week, like some part of that hour is to finish the current generation step, because when we generated, we saved data, so we can pick up from where we left off. As long as that data hasn't been deleted somewhere, we can just pick up and start again. Go ahead. Yeah, it's 250 gigs for the 7-character set unpruned.
Pruned approximately 120 gigabytes.
Right. So 120 if we prune it, and the pruning step is like we're going to do that because it makes sense.
That's based off of the data that we got from the 5.6 space, but we can only assume that it's accurate because DAS is used. I mean, it's statistically random output. It's used for FIPS certified PRMGs.
Which is fun, because now we have some more of that. So yeah, the pruning step, yeah, basically like you said, like hard drives. We wanted to have the data here so that we could at least like show it to you in some fashion. Yeah, it's going to be on BitTorrent when we get it done, because obviously, like, is there anything else we could possibly use other than just like, I actually did contemplate, by the way, I didn't have time to do it, but since I'm here and I'm talking and I have a pen in my hand, if you are interested in this when we get it, and because it's so huge of a data set, anywhere from 250 to 120 gigs, I did contemplate having like a little sign-up sheet or a little web app that you could say, I will donate a hard drive to this, and send it to me. I'll pay your cost of shipping and send it back to you with the data, so that you can have like a hard drive full of all LANMAN hashes ever possible. So if you're interested, see me or Patrick. The other, so if we get another window, basically we'll spend some more of that time finishing the generation step, and then the rest of the time on the pruning step, and then we'll be more or less done, right? It's important to point out what this doesn't apply to. This is LANMAN, so it doesn't apply to if you're using the stronger password hash in like Windows 2000 XP or later. If you turn that on,
They still have the LANMAN for reverse compatibility.
right?
You can turn it off.
You can turn it up, but I mean this does affect essentially like, unless you do some serious patching or some serious hacking, it does basically affect every NT4 system around, and everything earlier than NT4, so NT3. And to the extent that we can make credible numbers as to how many of these systems exist in the real world, it's hard to say. But being that we're in DC right now, I would imagine quite a bit. I mean, I know a lot of stuff has been upgraded to 2000 or later, but I imagine NT4 has not gone away, and people probably haven't turned off backward compatibility for a lot of reasons. I personally know, I won't mention names, but I personally know large financials that are running stuff on like OS2 kicking around, which is also using LANMAN. And, okay, so out of this, what can we say? I wanted to also point out stuff. Yeah, we have a paper which it says here by CodeCon 2006. We do have it in preprint. We have like a very 7-page preprint that Patrick put together and that we're working on editing, which is also done basically in May. We've edited it since, but the bulk of it was written in May. The paper will be out. We weren't, even if we had code, we wouldn't and data, we wouldn't be ready to release it today because we're trying to submit it to a journal and get it refereed and all that stuff because we think it's fairly important. It's not as though this is a huge. We're basically coming up with a better way of doing brute forcing for this very specific case. But this case is interesting because it's so weak. And so it's arguable that this model applies to a bunch of other stuff. Do you want to go into that? Do you not want to? No, that's like still negative end day. Okay. So if you get him drunk, he might drop some negative end day. I want to show the code, so let's get you up here.
Well, we basically talked about anything that would be discernible from a board.
Do you want to show it or no? Do you guys want to see what sucks about Rainbow Crack? Is anybody interested? If nobody's interested, we won't bother. Yeah? All right, sweet. While we're waiting, does anybody have any questions? I'm happy to answer whatever. Yeah, go ahead. Oh, you're twiddling. Yeah.
So like the 69 character key space, right? No, there's per byte. There's 69 permutations possible, not including null.
So this is like not alt character key space, right?
No.
Okay.
But the thing is about LANMAN is it converts any characters that don't meet that criteria into question mark, which is cool. Which is really cool because I found I used to do a fair amount of contracting in Japan, and you'll find the Unicode passwords where it'll be like all question mark via LANMAN. No, the only one, the MD4, which is the NT-LANMAN, is case sensitive and does take Unicode input. But there's other flaws that exist as a result of this for passwords less than 26 characters. But I can't really go into detail. That's a whole nother. That's like really lectury. But if you want to talk about it later, it's fine. To this one?
Yeah. Those are fun. I know. It's weird. Okay, go ahead. Hopefully you can see both of this. I don't know if you can. Yeah. Should we turn? I don't know if we can or can't. Sweet.
Do it. Take charge. Just do it. Screw budget. Budget?
All right. It's the right file, even though I can't see the last one.
Turn off color last.
Oh, this? Yeah, I know. Yeah, let me.
Set term VT.
Yeah.
And we have a laser pointer I can borrow quick?
Yeah.
I do.
It's a race.
Laser pointer sounds.
That's cool.
Ours is cool.
Yeah, ours is really colorful.
Don't.
Little button on in the middle somewhere.
Oh, green. Great.
Wow. Now that's not the one that fried the hole in the cup, is it?
How much time do I have? Sweet.
Oh, man.
Oh, this is not right.
Where in the hell is where it reads all of them?
Oh man, that's it. You're off the wall. Would you rather have that wall or the other? You can roll it closer.
Dude, really, I don't think we should go over this. This is like
Yeah,
somewhat
there you go.
pointless.
Tilt it up a little bit.
Yeah. Screw this. I don't want to read
Hold on.
through this Chinese
There's
guy's
a-
code.
Oh, well, so here, while you're doing something. So who here saw like my little brief blurb at DEF CON, if anybody? A couple people? All right, so you kind of all know the people who raised their hands know about the email we got. Before this ever came out, before we talked to DEF CON, before we were doing this, the guy who authored Rainbow Crack, I'm going to butcher his name and I feel bad about that. I think it's Zhu Zhangli, but I don't speak Chinese very well at all. Yeah, so the author of Rainbow Crack, I don't have the mail to put up here, I had it in the previous slide, sent us a letter, us being Shmoo, basically in this case Beetle, because his was the address that was on the Rainbow Tables page for Shmoo, sent him a mail in which basically he said, in a kind of ranty way and through a language barrier, that we were like, I think, I don't want to say it too strongly, but I think, he was like calling us out for generating all of the the largest, most accurate set that Rainbow Crack could generate, and then offering it for free on the web, right? And he basically said, who do you think you are? Do you think you're so cool because you're a hacker and you can take this free tool and then download it and run it and then give it away for free? Like it's not cool, blah blah blah. There was no discernible license on his code when we got it, but it was pitched as a tool that people could download and use. I mean, plenty of people were, and he wasn't bitching about it. He was, however, selling DVDs of large character sets, including the one that we did, the ultimate, like the LM symbol space character 32, the one that includes everything that's a valid input character for Rainbow Crack. He was selling it, I think, for around, you can check his website, it was either $400 or less, like $400, yeah. And he was, right, so he was selling it on his website, and so a couple people basically said, well, he's just basically mad at us because we're giving it away for free and he's trying to sell it. There are also tons of other people who are selling this, which we basically see as, okay, go ahead, like knock yourself out. It's not going to stop us from offering it for free. I mean, if you believe that you have a business around it, then go for it. The interesting thing is that there's also, who's seen the online like subscription model that some guy did? I mean, I don't know if he's here, yeah. Rainbow Crack Tech. Okay. Oh, okay. Yeah, so they're using a subscription model. Basically, you sign up. I only know about this because I got called about it by Rob Lemos, who asked me like, what do you think of the utility this is? They're like, well, you can generate it and put it online, and people may pay you money for it. I mean, that's okay. I don't see it as being very valuable because I don't know how much resources he has or whatever. I mean, presumably he get a lot. But a subscription service seems weird because it's like it would only possibly work in a statistical context, right? You can keep taking money for something and keep generating hashes because you're never going to get complete. Right? You're never actually going to finish. You're just going to add more nines to the probability. So it's like realistic that you could keep just generating stuff. And then the other thing is that people have been using Rainbow Crack's method since it added the facility to do this for MD5 and SHA to do that, which I think is ludicrous because, yeah, nobody uses it because I think he generates everything unsalted.
Yeah, there's no way you could, generate it salted the way that Unix uses MD5. It would take you more disk space to store one single input value for the salted MD5 than it would the entire key space of LAN.
So, and then SHA obviously is also like similar to MD5 but different and has a similar property. But people are doing it for just MD5 unsalted, which I guess is interesting in as much as it's interesting for like maybe files checksums and stuff. Birthday attack, right? Which is a good segue into Patrick's recent work on MD4 and MD5. So, you don't want to talk about it? He's too hot. It's really hot up here. But I mean, I'll talk about it a little bit. Do you want me not to talk about it?
Oh, no, go ahead.
Sweet. Because it's cool. I mean, has anybody seen Patrick's MD5 and MD4 work? Raise your hand. Okay, well, all right, Rich, and a couple other people. Great. Go check it out. It's at stachliu.com. It's STACHLIU.com.
Only thing there.
Yeah, so you cannot possibly miss it. And basically, what he wrote was collision generators. This is based off of the same attack that got presented at crypto a while back by the Chinese researchers. We're not against Chinese people or Chinese crypto researchers. Don't think that we are.
I actually had some pretty interesting dialogues with the people that did the MD4 and MD5 stuff. They were computing hashes at about 1 hour on a 32-way.
You're hot. Sit down.
On a 32-way IBM P690, which is a Power 5 big honking machine. And there's a few of the corollaries that they had where you could make it more deterministic and actually solve for it in a reasonable amount of time on a regular PC. So that was pretty cool.
Hand me my laptop, can you? I'm going to actually... What's that?
Well, the problem is it's a commitment thing. This sweater, if you put it on, it leaves fuzz all over you. If you take it off,
We're fashion conscious hackers up here. So, given that we can't get exactly what we want with the AB thing here, I'm gonna show you the email. If I don't kill myself first.
Did you get that on tape?
Well, I don't want to. Yeah, I mean we could, but I don't really want to. You can all see that, right? Sweet. So let me see here. Yoink. No, I don't. Specifically for that, because I knew I was going to get that question. So let me see if I can find you the mail that is relevant to this. Give me 1 sec. No, I'm not. I made damn sure that I was up to date and then some before I came here.
It just says you have updates ready.
It does, but that's because Windows Update is modified on this system. So give me 1 second. I'm going to bring up some stuff. Where am I looking for? Oh, yeah, here it is. Cool. Oh. It is possible, though, that I could be using a hacked wireless access point right now. I can't really rule that out. Oops. I want that. It's sort of my best friend. As long as it's not based on OpenSSH, it might be. But don't let me get into that argument. Patrick wanted to point out one thing, which was that we really, I know that there's people here at Shmoocon who I know personally who helped us out getting in contact with SGI, and I really appreciate the fact that they did that. So I don't really want to hound them or make them feel bad or refuse to help us later because we treated them like crap, because I think that it was really nice that they did it in the first place. But I know the people at SGI who I worked with to get this to run were also very facilitating, and given that they were doing it for free. But if you're at SGI, or you know people at SGI, or you're one of those people that I'm sort of vaguely mentioning, please help us get them to talk to us again.
But it was going to be done in 57 hours. It's been half a year. And
Right.
no data back. I mean, we were banking on the fact that within half a year we would get the data back.
We're doing good cop, bad cop here, right? I mean, he's obviously more pissed than I am, and I'm not very happy with it. But at the same time, I realized that it was a donation, and these things happen. On the other hand, if you have systems that can help us out, and you can get runtime on them for these kinds of projects, we're planning to publish, right? We're not trying to be nefarious about it in any way. So it's not as though we're going to rule the world with LANman or anything.
I was about to say, the SCI sells to NSA. How much you will bet that will stop?
LANman? Are you serious? I mean, I honestly don't know. I guess it's possible. I mean, I would tend to think that LANman is something the NSA looks at and eats without thinking about it, right? I mean, I would say for breakfast, right? But it's kind of like a piece of gum or a chiclet.
They haven't called you? They haven't talked to you?
No. I mean, maybe they will now, but I mean, maybe they'll call me and you won't see me again. I don't know. The people that I know people that say they're fine people. I mean, so I don't know. Maybe those are the ones they want me to know. If it did, that'd be a huge dead giveaway, I guess, right? Why is this not loading? Oh, there we go. Sweet. This mail is kind of funny. I know. I'm specifically not on the projector until I can get this mail up so that people can read it in its glory. We're doing really good on time. We have 20 minutes. Other questions while I wait for this email to come up? I'm using IMAP, so it's my own damn fault. What's that? We got plenty of time, though. You're hot. You can get off stage if you want. You're just a glutton for punishment. You won't get off stage and you'll take the sweater off. Yeah! Take the sweater off. Woo! That's how you got to start a con, man. With stripping. Yeah! Yeah, you're fuzz free. You're not in the light. Nobody will see them. Regarding the NSA thing, yeah, I mean, anything's possible, so I have no idea, right? I mean, it's all supposition. But if that's why it got turned off, so one thing we didn't really go into in detail on this, but is true, is that because we haven't gotten stuff back from SGI, and it's been half a year, we've been trying to work around that fact. So what Patrick has done with some.
I wrote a distributed version of the computation. I wrote a distributed version of the table computer. The only problem is that it requires more time at pruning, and we do need a machine initially to compute a seed to distribute the pieces of work to the rest. It's basically a sparse matrix, and that's the pieces of work that go to all the clients. And yeah. Oh, for the individual clients or for the one to compute the seed? For the machine to compute the seed by memory, it doesn't necessarily have to be RAM. Although, like I mentioned before, swapping is extremely painful. I mean, if you go from 32 to 64 gig, you're doubling performance literally, just from the lack of swapping from the memory back file. However, that's still a drop in the bucket when you're talking 800 plus gig and the distribution of deaths being statistically random. That basically you're going to be beating the hell out of your disk regardless. So for that, I'm grinding away right now on a machine with 32 gigs of RAM, and it's painful. And it's not even through like the 512 upper marker of the seed. And it's been running like 2 weeks. So I'm estimating another 4 months for just the seed. So trying to upgrade that machine in the meantime. But modern PCs aren't really designed to put a whole lot of RAM in. That's the one thing the vendors really cheap you on.
I have the email. This is mostly of novelty value, but let's go. Presentation on projector and ThinkPad. Will that work? Let's check it out. Y'all see that? Is that good? Oh, it's like, thank you very much. Whoever adjusted that. All right, so this is the email that we got, and you can kind of read it. I made the font big. Everybody can read that, right? No? No? Can make it bigger. No, that doesn't work. All right. So, I mean, you know, here's, right. Here, because this is what we said on the website, right? On the rainbowtables.shmoo.com website, we said because knowing all the passwords is cooling than trying to crack one, which I think is true. All over the world, there will be a lot of guys can do what you do. They aren't. Do you know why? To rush off, no, blah, 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 blah. Here's where it gets weird. Don't be crazy anymore.
The one part that I found funny when I first read this was the intellectual property part, because actually, like, none of the code is based on a method he came up with.
Right. It's all prior art, and there's no license in the code, which I'm not sure where that puts us copyright-wise. There's no distinct license, but it's offered for free.
But it's also craft. So free craft is still craft, though. That's
Right.
what you have to remember. With anything, it's like you can have like a free brick of lead, but would you want to drive it to work?
Here's where I get here's where this like logic breaks down for me. If possible, please keep honor of my intellectual property of this software, and let those need the tables to generate them by themselves. If everyone act like you, there will be no reason for me to develop the software further or develop other useful software, or I will never release anything useful to the public. So, like, you know, initially we had technical reasons for not using Rainbow Crack, and then after this mail, it just like gave us tons of social reasons, right? Like, you know, if you wanted to stop me, this is like the least way it's going to happen, right? You could have been, I don't know, give us some runtime and then not give us the data. So anyway, that's the email we got, and that was kind of the thing that spurred us on. At this point, you know, we have like I think 15 minutes. I told you we had 50 minutes. We have 10 minutes left. Is that right? Okay, thank you. Who wants to know what while we're up here? Go ahead. Sure.
LANman because it's a reasonably small key space, and people, you know, using it on MD5 and it not being salted, it's just silly. Because what can you do with that? But you said, you know, this was an interesting, elegant solution because you could apply it to other, you know.
It's potentially applicable insofar as, well, first Hellman's method, right? Hellman tables, and then Philippe Oshteen's. I'm butchering his name. I really apologize to Philippe Olstein. There's no T, but okay, Osteen. I talked to him over email, but I still don't know his name. His method, his adaptation of Hellman's method is also interesting for that merge reason. We don't like it for the statistical reason, but it's interesting for the merge reason. And he has grad students. He works at a university. He has grad students that are currently working on another version of OPH crack or OF crack, which supposedly also gives full coverage, but we haven't really talked about. We've talked about it only insofar as I know he's doing it, or that some grad students working on it. We think this method would be applicable to other things, insofar as how we've gone about, you know, for other things that have similar weaknesses or that have similar complexity requirements, right?
So you're saying more how you solve certain types of
Right. MD5's complexity requirements are huge, right? They're way outside the bounds of the complexity requirements of this. Right. It's infinitely bound, which is not the case for LANman's implementation, right? And same thing for SHA-1. And pretty much more or less the same thing for almost any hash function that's like reasonably developed. I mean, there's edge cases that don't apply. But the reason why we want to publish it as a paper is not because we think that it's like, you know, a brand new cryptographic attack. It's just a method, but it's an improved method that, you know, builds on his work, and which builds on Hellman's work, and this is what you do in, you know, in mathematics and cryptography in general. I mean, and also, speaking of MD4 and MD5, the much more interesting thing at the short term is the collision work, right? Being able to generate collisions, basically invalidates the use of MD5 as what it was intended for. I get these arguments from people who say things like, well, MD5 is better than CRC32, and for regular files it's fine because, you don't want to spend all that time computing SHA-256 or whatever, right? And I'm like, well, if it has any chance of failing practically, I mean, there's always theoretical breaks, but if there's any chance of failing practically, why would you use it, right? The whole thing about cryptography is that you shouldn't use something you know to be broken, right? It's the whole reason we moved off the desk. There's also this AES attack that I've been looking into, Bernstein. Does anybody know the Bernstein AES attack, the cache timing attack? Nobody?
Yeah, the thing with the little cute visualization that looked like a graham cracker.
I haven't seen that.
Yeah, it looks like a graham cracker.
So while I'm up here, I'll mention other cool crypto stuff I'm into. Dan Bernstein, who was a prof at UIC, University of Illinois, Chicago, did a thing with AES, which is where he basically, software implementations of AES are vulnerable to this cache timing issue. He exploited this with OpenSSL, and a specific version of OpenSSL he modified to display exact timings of input values into the AES routine and then their exit. And basically what he does is you can watch enough traffic that you know to be encrypted with AES, i.e. SSL, and you watch enough traffic and you generate, all you have to do is watch enough traffic over a certain amount of time, and you can detect on the basis of timings and responses from the server when things fall out of L2 cache, when you can force a cache miss, and then use that information to actually to extract key material, and then attack AES. And there's this big debate back in April on Sci.Crypt and Usenet where everybody was saying, this is not practical. You can't do this in the real world because latency on the network is too great, and it never pulled off because if you're 30 hops away, you can never realistically know what your timing is going to be. And Dan Bernstein's basic rebuttal is, I didn't know that we designed AES to be secure as long as you're more than 6 hops away from a network or from a node that's using AES to secure traffic, right? He's, and everybody else is basically saying, well, nobody's broken this yet, nobody's done it yet. So, of course, there are people looking to do it, in the real world. Maybe we're one of them. Go ahead. I did, but I haven't talked to him about it. So, I think, Todd, where are you, Todd? 5 minutes. Okay. I think at this point we're pretty much done. If you do have, I want to make an appeal. If you can help us get runtime, we'd really love you. I mean, we'll give you credit in the paper and everything else because that's what we do. Yeah, and we do have a preprint. We're looking to submit to like an actual journal to get it published. And the idea is, again, if you want the data, we're releasing the data because we're generating the data, with everybody that we've gotten agreements to help us generate data has basically said you can do whatever the hell you want with it. I mean, we'll just help you out. So we're going to release the data. There's more work that comes after this that we want to get onto, so we'd like to finish this project. And we want to give, the whole idea that we say this is breaking LANMAN forever is that we really want people to stop using LANMAN. And, up until now, and up until Rainbow Crack, there were excuses as to why you could still use it, although it was a dumb excuse. And even with Rainbow Crack, people still basically said, well, nobody's going to generate, the largest key space. Well, we're giving that away for free, and not only are we giving it away for free on the torrents, but there are actually 11 DVD sets available as prizes here at Shmoocon that you can get that have like the whole Rainbow Crack, largest or most accurate key space, the one that includes everything, including space. So check out the contests and stuff. I tried to finagle getting a couple for here, but I didn't get any. And then even after that, having every single possible LANMAN hash will, I think, pretty much invalidate everybody who's trying to build a business off of this. Not that I'm gunning to do that, but yeah, it's a stupid business. I'm sorry, right? Like, it's just kind of dumb. I mean, if you can make a buck on it, more power to you. But eventually, we will be the low-cost provider because our cost will be $0. So, all right. With that, I'm done. Thank you very much for listening. Thanks for the comments.
Thank you. Bye.
Sorry. Yeah, they're bright. They're very hot.
So you remember a night of heavy drinking at the first visit and talking with you about generating.
Good. How are you? Dan, nice to meet you. Let me just hibernate this for a second. You know what? Like, I have a pen and I have my notepad. So hold up a second.
Actually, in contact with Travis, he's the creator of Rainbow Crack Online.
Oh, really? Is there? Oh, it's Rainbow Crack Online. Oh, okay. Rainbow Crack. Oh.
Little line.
I was like, what are you talking about? Okay. Oh, yes. I do.
She wants her expensive laser pointer.
You know, I feel bad 'cause I didn't even get to use it, like with the code.
Do you have a car?
Yeah. Yeah, I actually don't have a card. I'll make it.
I say that because a lot of people don't know. Sure. But yeah, actually, last episode we talked about Rainbow Crack Online, so it would be great to follow up with you guys.
What do you guys think about that?
It's interesting. Actually, the funny thing is the API has been built into a network distribution of components. We use security obviously that some of our friends did, and it's free. Yeah. So it's funny, he's doing a subscription service, but the API is not free for this if you support it.
I don't really think. I mean, I personally think this stuff doesn't mean you shouldn't do it. It's going to make money, right? Like, I mean, more power to him. You know, and as long as you know.
I think the reason, mainly the reason he's doing it is to cover operating costs.
Have you guys thought about doing something like setting up at home where you have distributed clients and then
Yeah, the problem with that is, again, we need machines that are beefier than the average response.
Fuck you.
Every time we go across an IO boundary,
Yeah,
My name's Todd.
I'm Billy Hoffman.
I'll be raising my hand in the back.
Okay.
Letting you know what your time is.
Okay.
Somebody else is actually going to introduce you.
Okay.
But how long's your presentation?
It's going to be the full hour.
It's going to be a full hour.
I mean, I shouldn't run long, but I got 63 slides, and some of it's kind of complicated math, and
Okay. Well,
I will
you
do-
get about
I-
55 minutes.
okay,
So
I should be able to keep that.
I'll let you know at 45.
Okay.
And then, so 10 minutes, 5 minutes.
Then I'll
and
just
then
run
I'll
through shit
start
really
throwing
quick.
balls.
Oh, okay. How many Shmoocons do you have? Because maybe I could just duck the first couple and be okay.
Actually, I got
Ah, well,
hit earlier. It's painful.
that would suck.